On number 9, let's draw the ground, and then we have a tall building, and you're like sort of resting on top of the building. And it says with an angle of depression of 70 degrees, you look down and notice a car. So let's say a car is down here. And your eyes, look, your eyes would go like that. But because this is such a nice car, your eyes actually point this way. So your eyes went down. And that's your angle of depression, which is 70 degrees. But based on geometry and alternate interior angles, we remember that this angle is the same as this one. They sort of just like switch inwards. They're the same measure, alternate interior angles. So we know that's 70 degrees. And let's see what else. The car is located 65 feet from the base of the building. So this is 65 there. And the goal is to find, it says, the height of the building. So let's just call that H for height. So here we have an angle. That's our angle theta. And this is our opposite, and this is our adjacent. So we ask ourselves, between sine and cosine and tangent, which one operates with opposite and adjacent? That'd be tangent. So we need the tangent of theta equals opposite over adjacent. But we know what theta is, 70. And we know the opposite is h, and we know the adjacent is 65. So we have tangent of 70 equals h over 65. And now the goal is to find the height of the building, which is h. So here in green, we can multiply both sides at 65 because these cancel. And then here, this green bubble, what I'm doing now that you can't see because my camera is off, I know, but I'm going to type in 65 times tangent 70. And my calculator says about 179 feet for the height of the building, which was the goal. So to the nearest foot, about 179 feet for number 9. Now looking at number 18, where are you? Number 18. There we are. Find the exact value of this right there. So let's see. I would begin by looking at the inside. Let's take secant of pi and do some scratch work over here. Secant of pi. Well, remember a fact. Secant of theta is the same as 1 over cosine theta. So based on this fact, secant pi is the same as 1 over cosine pi. And then from here, how much is cosine pi? You can go calculator if you want to, and you'll see that cosine of pi is -1. So it's 1 divided by -1, which is -1. And this -1 equals this, which equals this, which equals that. So going back to the main problem, we have tangent inverse. Now in the parentheses, secant of pi is equal to just -1. And now the routine is whenever we see a tangent inverse or anything inverse, we go equals theta. And then we want to get rid of tangent inverse. So what we can do here in blue is we can take the tangent of both sides because these would cancel. And then it would say tangent of theta equals -1. And this now becomes unit circle. Where on the unit circle do you go? So that tangent is -1. And recall that tangent is like the y divided by the x coordinate. Where do I go so that the y divided by the x is -1? Well, look, that someone would say that happens here because there the coordinates are like square root 2 over 2, square root 2 over 2. And if you divide these numbers, you get 1. But the problem is I need -1. So this one is no good. But what does work here in, let's use the color like purple. What does work is this location here, but also this location there. Because if you look at the unit circle, here and here, the coordinates are the same, but one's negative, one's positive, one's negative. And if you divide them, which is what tangent does, you get negative. But now the question is, which of these two is it? Well, that's when we remember that from the lecture the other day, that tangent inverse goes from here to there. So this one's no good. It's outside the appropriate window. So this one wins. But now you got to pick the appropriate name. Recall from our notes that if you're dealing with tangent inverse, then your angle has to be between negative pi over 2 and positive pi over 2. And an appropriate name for this location would be negative pi over 4. And I believe that that's what it should be for number 18. Watch, let's take a gander here. Well, the answer key should be given to you guys. I think I printed the answer key. So for number 18, it should be negative pi over 4. Now for number 19, let's do the inside first. So the cotangent of 3 pi over 4. Well, remember that cotangent is the same as 1 over tangent. So let's rewrite this as 1 over tangent 3 pi fourths. And I did this because my calculator, which I have in my hand, I know you can't see, again, the camera's off, but the reason I did this is because my calculator has a tangent button. And I'm typing in exactly all of this in my device, and I got back -1. So going back to our main problem, this would become sine inverse of -1. And then the routine is that whenever we see inverse, we let it equal theta. And then we take, in this case, the sine of both sides, because these cancel. And so we have sine theta equals -1. And what we want is for sine, or the y coordinate. Think of the unit circle. Where on the unit circle do you have a y coordinate of -1? So I believe that only happens down there. And I know the unit circle calls this 3 pi over 2. But nuh-uh. We were dealing with sine inverse. The original problem said sine inverse. And when it's sine inverse, your answer has to come from there and there, where this is pi over 2, and this is called negative pi over 2. So this guy is the appropriate name for the angle that takes you here, which is why the answer key for 19 says negative pi over 2.